Hello everyone, this is Gaussian Gamer. I've not posted a video in a while, but, well, recently I've been playing Minecraft, and so, yeah, I was looking on the interwebs and saw that you could do some pretty neat stuff with some redstone. As a math major CS minor, I decided to try making an 8-bit adder in Minecraft. Unfortunately, it is only an adder, not a full ALU. It can only add, but it does have like some sort of memory. It can store variables, as you can see, variable A, variable B, super fancy, and output. So this is the kind of 9-bit output, especially with this carryover from the two 8-bit variables. As you can see, it goes 1-bit, 2-bit, 4-bit, etc. This is the input with the levers. As you can see, turning it on puts that output over to here, which is these two variables, namely the storage units for variables A and B. And for more of a quick summary, here are the actual adders. I just found these off of Wikipedia. Pretty easy. And then these signals I'll just kind of split out and bounce around. I'll show those later. But more for just a proof of concept, let's go over to this. This is just a basic full adder. As we can see, none of the signals are currently on. This piston over here is just the single output, and then this piston right here is the carry. So as we can see, if we were to take 1 plus 0 plus 1, oops, looks like I switched out the carry and the output, whatever. So there is the carry, which is 1, and the single output, which is 0. However, as we can see, this is a very space inefficient type thing. This right here constitutes an XOR gate, another XOR gate, some AND gates, the OR gate, relatively basic stuff. But it is far from space efficient. What I actually used in my full adder is just this system right here, and then I just lined up 8 of them together. As you can see, this is the carry system between the different adders, and this is the input system into the adder. However, in order for this adder to be particularly useful, I had to give it some sort of memory. So, for the memory, this is a system that I devised. Really, the only thing I looked up on Wikipedia was how to compress the adder. Everything else is, I don't know if it's novel, but I didn't really look at any particular source. So as we can see, we're just using redstone repeaters. These are just powered by 2 NOT gates, which will latch these 2 repeaters. Pressing this button will delatch these repeaters. As we might know, repeaters, when locked in the position, will keep the current state of the repeater locked. So, as we can see, moving these levers does nothing, does nothing in particular to these until we remove that, and boom, and it locks these into position. As we can see, those 2 redstone lights remain on. So that was the basic storage unit and memory here. This is that exact system just spread over to 8 inputs instead of just 2, which will then feed into the adders. As I said before, these are 2 separate storage units, namely A and B. They are fed in by either the output signal or the input signal, and then split up into these 2 different variables. They are then re-fed back in to these adders, output via this lower system of redstone wires, etc., and repeaters. And then in this lower layer, get fed over to the output system, which is right here. As we can see, they're just blank variables, but, you know, whatever. So, well, in order to be able to see what these variables are displaying, which is certainly useful for doing various types of calculations, I just split up the outgoing signals from the variables, namely one going into the adders, one feeding back into these displays, which is right here. And then just for kind of like a proof of concept, let's just take 5. Notice that this is the 1-bit and the 4-bit. Nothing has been added yet, much like in the smaller system, it waits for an action. I'll get to that lever in a second. That's kind of an interesting little tool there. But then we take this current input and store it in variable A. Looks like there's another lever here that shouldn't be there. And yes, store it in variable A. So we have 5 in variable A. Now we're going to want to move an 8 into variable B. And there we go. There's an 8. There's a little bit of a calculation time. This is very much a brute force type thing. There's no look ahead unit or anything like that. It's a pretty simple system. I only just got into this a couple days ago. However, I wanted to be able to do things like calculate the Fibonacci sequence. Being able to calculate the Fibonacci sequence in Minecraft would just be hilariously entertaining. So in order to do that, I had to be able to feed the output generated into one of these variables. And that's exactly what this switch does right here. It'll switch the feeds between taking what is on these input levers and what is from this output by using a series of AND gates. As you'll notice, these AND gates are powered from above, right here, which leads back all the way to this lever. The lever powers this system. One of them is attached to a NOT gate, the other one is not. As you can see, this system leads us over to here, which is an identical system, except instead of being hooked up to directly via the inputs, it is hooked up to the output system. And notice the way I did this was I, again, just split the signal from the adders. One of them goes to the display, the other one goes into the feed. And yeah, and that'll just switch the signals. Again, it just passes them in. It's an OR gate, or sorry, it's an AND gate, which just passes the signal. Only one of them can work at a time, etc., etc. So it doesn't matter what position the levers are in. So, as a demonstration of this, let us just count the Fibonacci sequence, reset the system here. Note now both variables are at 0, so we will put a 1 into A as such. And now we will utilize the output system. So now it'll take this output and store it into variable B. The way I currently have it set up, it's not perhaps ideal. I might want to modify it later. But it puts the lower 8 bits into this new variable and just ignores the carry. Again, not ideal. It means that the largest value you can have stored in this system is 510, as opposed to a calculator, which will have some exponential value, allowing to go to higher values. For the output, I might modify it later again, but I just spent 8 hours today building this in one sitting. Kind of tired. Don't want to modify it anymore right now. Anyways, so we will move this current output into variable B, like so. There we go. So we have 1 and 1, their sum being 2. So, as we know in the Fibonacci sequence, we have to set one of these as our new variable. So I will move the current output into variable A. There we go. And now we have 2 plus 1 is 3. Once again, move that into B, and now our sum is 5. Just do this a couple more iterations. Next sum is going to be 8, and 13, etc., etc. So yeah, just kind of a cool little system here, kind of proof of concept. There's some kind of other stuff scattered around here, like this is a demonstration of a combo lock that I found online. These are some new elevators for another world that I have. But yeah, this is not a particularly space-efficient model. As you can see, these are just 8 wires, just kind of spread apart. I built this particular system early. This is the display for variable B, variable A. I did that a lot earlier on. As you can tell, it's only 8 wide as opposed to 16 wide. This is some of the last functionality that I did right here. I was tired, so it's, again, not very space efficient. But yeah, so once again, just to recap, this is the whole kind of input system. Oh, something that is worth noting. As you can see, when you have something in the input, just put in some random thing here, doesn't really matter what, it will split it between both of them, both variable A and variable B. Variable B, A and B are mirror image, but as you can see, here's this general pattern: off, on, or off, off, on, off, off, on. There will be this exact same pattern here, because it is just split by this kind of bleachers type thing. I don't really know what to call it, but it'll just split it evenly. And pressing those update buttons merely releases this latch, and that is all it does. So it allows you to store the new variable in the system, and then it'll just automatically sum it. There's really no like counter system, no external RAM. It just automatically runs to completion and then finishes. I had an earlier model which would have store as variable A, store as variable B, but instead of just being output versus input being determined by this lever, I actually had 4 buttons, which would just make it so that I didn't have to keep toggling between this. It was kind of working okay, but I was having some timing issues, largely because of these repeaters. I was just getting funny glitches. Didn't work out particularly well, so I just chose the toggle system instead. But yeah, I don't know. I guess largely kind of a successful test of how to do large scale, well, not perhaps large scale. I've seen 32-bit systems in Minecraft. They're kind of over the top. Don't really have time for that in my life. But yeah, it's a good demonstration. Hope you enjoyed the video. Thanks.